Alright folks, thanks for coming. Today we're gonna deal with exponents. After exponents, then we'll move on to polynomials. Okay, you can't really talk about polynomials without understanding what exponents are. I mean, again, you could, but it's better to talk about exponents first before we talk about polynomials, okay? Because polynomials use exponents, okay? So it's better to understand what exponents mean before we then go talk about polynomials. So we're gonna deal in this video about exponents. We're gonna explain it, and then we will solve a bunch of problems, okay? Now, before we start, please subscribe to my channel, like and share this video. If you have any question or comments, leave it under the video. I will get to them as soon as I can. Alright, so we're gonna deal with exponents, man. You see the pictures there, I put them there on purpose. You see, look at the picture on the left. It's actually on the left top. It's 5 raised to power 3. They say 3 is the exponent and then 5 is the base. That's what that thing is saying. And then look at the one on the right hand side, the top right. It has 3 raised to power 2. I will explain that as we go. Some of you know what all this means. You see, it says 2 is the exponent, 3 is the base. And then 3 raised to power 2 is actually 3 times 3. 2 times. That's what that means. When you raise a number to the second power, it means multiply that number 2 times, okay? 2 times. I don't know what they're writing there. 2 times, okay? That's 2 times, okay? You multiply 3 2 times, okay? And then look at this one. This is a general from the one on the the bottom down. It says n is the exponent, b is the base. And then it said b raised to power n is b times b times b n times. Okay? That's basically n times, okay? N times. Alright, that's how you multiply. How many times you multiply b? Alright? And then look at the one on the bottom right. You see, it's a raised to power negative n. You see what it's doing? Is dividing. You're dividing one with the n. With a. Forget about that. I will explain that later. You're dividing one with a n times. So you say 1 over a, 1 over a, 1 over a, n times. Don't worry. I will explain all that. I'm gonna explain all that. So I just want you to see. You've probably seen all this before in the past. So we're gonna explain it, okay? Thanks for coming. So let's go. I will do explanation, a bunch of explanation, and then we'll solve a bunch of problems, okay? Alright. Okay, see the numbers are listed there. 7 raised to power 1 is the same thing as 7. So it's called 7. See, I just said it, but I'm supposed to explain 7 raised, okay? You don't have to say raised. You can say 7 to power 7 raised to power, okay? Power 1, or you can say first power, it doesn't matter. Alright? And then this one is 7 times 7, okay? So you can say this is 7 to power, power 2. So 7 raised to power 2. Okay, look at this one. You can say this one is 7 times 7 times 7. That's what that means. So that's 7 to power 3, okay? Now look at this one. 7 times 7 times 7 times 7. You see what that means? So this is 7 to power 4. You see that, right? And then look at this one. This is 7 times 7 times 7 times 7 times one more 7. So that's 7 to power 5. You see that, right? So I took my time to show you this, okay? Now, you see, when you say 7 raised to power 5, right? 7 raised to power 5. So basically 5 is called the exponent, okay? You need to understand that. We'll have terminologies here for you. So make sure you get that right. This 5 is called the exponent, okay? And then 7 is called the base. It's called the base, okay? The base. The base, okay? Base and exponent, okay? You see that, right? And then we'll call the entire expression 7 raised to power 5. We'll call the whole thing the exponential form of something. Form of what? 7 times 7 times 7 times 7 5 times, okay? So because that's what that means. So this one is the exponential form of that one. That's all. So make sure you get the terminology correct, okay? Make sure you understand what each term means. Now, if we then have the number, let's say a is any real number, okay? Real number, okay? Right? And the n is any positive number. Any positive, okay? Positive, we can say positive integer, okay? Okay, so then a raised to power n is the same thing as you know what that means from here. It's a times a times a times a. You keep going times dot dot dot. Keep going. I'm sorry, hang on a minute. I have to write it correctly. That way you don't get confused. You keep going. You do 3 dots times a. Okay, n times. Okay. You see that, right? So if you have a raised to power 2, you will be a times a 2 times. You see that, right? 2 times. Okay, if you have a raised to power 4, it will be a times a times a times a 4 times. 4 times. You see that, right? That's what we mean when we say that. Okay? Alright? So basically, like I said, the 4 is the exponent and the a is the base. Sometimes they say 4 is the factor, or the, what I call that, the power. Okay? So, but it says the same thing, okay? You know, so that's what is going on there. Make sure you understand that. If you understand that, then you halfway home. You know, but there is a nuance though. Let me explain something to you. There is some kind of nuance. You see what that is saying, you see? What that is saying is a times 4 is saying to use a 4 times, okay? 4 times in multiplication. You see that, right? Multiplication. That's what we just did. Use a 4 times a multiplication. You see that, right? Multiplication, okay? Use a 4 times. That's all that is said. You use a times a times a times a 4 times, okay? Now, notice that all the exponents I've shown you so far, they're all positive. 1 positive, 2 positive, 3 positive, 4 positive, 5 positive, okay? Here 5 positive, here n positive. In fact, I even said it here, any positive number. Suppose n is negative, okay? Okay, now we've been talking about positive exponent, right? Now, supposing you have a real number and negative, right? Then what do you call this? That's how you get that is 1 over a times 1 over a times 1 over a n times, okay? Now they call this positive exponent, and they call this negative exponent. You remember the convention? We have this convention. We don't say positive 5. We say 5, okay? But if it's negative 5, we have to say negative 5. Alright, so the same thing here. Normally we don't say positive exponent, we say exponent, right? But when it's negative, we have to say negative exponent. That's the same thing as the convention here. Okay, so basically you need to understand those two things, right? A raised to power negative n, right, is 1 over a times 1 over a. Basically it's opposite of the other one. Is the other one, this one here, this here, that's a times a times a. Okay, that's multiplication. It has to do with multiplication. This one has to do with division. Okay, this one divides 1 with a n times. That's all. Okay, so it's like I said, this is positive exponent, negative exponent. Now notice this: a raised to power n says use a n times in multiplication, and then this one here, a raised to power negative n, says the opposite thing. Okay, division is the opposite. Division is the opposite of multiplication. It says use a n times in division. Okay, so I'm just showing you different ways they say it. This is regarded as positive exponent. It means multiply. This is regarded as negative exponent. It means divide. Okay, so make sure you understand that, because if you understand, then the rest of the stuff we'll do will be a little bit easier for you. Okay, let me give you an example. What of 8 raised to power 3? See, you say 8 times 8 times 8. What of 8 raised to power negative 3? You say 1 over 8 times 1 over 8 times 1 over 8. And I remember the image I showed you at the beginning, right here. This image here. Let me go back. You see this image? They had this. They have a raised to power n is something as equals to 1 over a raised to power n. Yes, that's correct. But I didn't want to confuse you initially. So, and think about it. 8 raised to power 3 is the same thing as yes, the same thing as 1 over 8 raised to power 3. And notice that is the same thing as 1 over 8, right, times 1 over 8 times 1 over 8 3 times. Notice that 3 times. That's the same thing as that. Okay, so always remember that it's multiplication. This is multiplication, this is division. It's a form of division, but it's still a multiplication is involved. You see, we said that multiply. Okay, all right, let's look at these examples here. I listed out a couple of stuff here. All right, that way it helps you understand what is 8 raised to power 3 multiply with 6 raised to power 4. I mean, remember our definition. 8 raised to power 3 is the same thing as 8 times 8 times 8, right? You put that in bracket, and then you do the other one. 6 times 6 times 6 times 6 4 times. You see, that's all that is saying. Okay, what of this? This is a raised to power 4, b raised to power 3. What is that? The same thing we did up there. A times a times a times a, right? 4 times. And then b times b times b 3 times. That's all. And then look at that one. That is that's the same thing. I want to show you something. Just I don't want to show you the next one. That's the same thing. It's negative, right? It's the same thing as 1 over 5. Same thing as 1 over 5, right? Times 1 over 5 times 1 over 5. Make sure you understand that. And then the other one, 1 over 6 times 1 over 6. You see that, right? Okay. Now, record the video the picture I showed you at the beginning. That can be written as that. And that can be written as that. You see that, right? That's what that picture. Let me go back to that picture. And that's true. I just didn't want to come. See what it says? It says right there. This one here. Okay. So I just didn't want to confuse you. So I tried to cover that picture. But, okay. So, if you look at it, you're going to arrive at this too. Look at it. It says 1 over 5 times 1 over 5. You do it 3 times, 1 over 5. Okay? 3 times. And then times 1 over 6 times 1 over 6 2 times. You see the same thing. Those are the same. Okay, check it out, okay? The same thing is a raised to power negative 2 and then b raised to power negative 4. Notice what is, you just do the same thing. 1 over a times 1 over a 2 times, okay? And then times 1 over b times 1 over b times 1 over b times 1 over b. See that, right? 4 times. That's all that is saying. Now look at this one. It doesn't have to be a and b. It doesn't have to be number. It can be anything. You just use this, whatever they give you, you use it to expand it. Okay, x, let me see, this might be a little bit confusing. X times x times x, okay? Alright, and then what is that? Y times y. Okay, notice that I can use red here. Times 3 times, okay? That way you can see it. Alright, what of this one? This means x times x times x times x 4 times, okay? We can go ahead and use red for that. Times 4 times 1 2 3 4 4 times, okay? 1 2 3, yeah, 4 times. And then the other one is x times x times x 3 times. You see that, right? See that? 3 times, you see? So you're multiplying 3 times here, you're multiplying 4 times here. So it doesn't have to be s, it can be w. What is that? That is w times w times w 3 times. And then another w times w times w times w 4 times. You see that, right? So I'm doing a bunch of these, when we solve problem, that way you get hang of it. Because we're going to solve a bunch of problems too. What does that say? That says 1 over w, right? Times 1 over w 2 times. Alright? And then it says 1 over w times 1 over w times 1 over w 3 times. You see that, right? So make sure you get hang of it, man. You gotta get hang of it. Go through this. I'm sure I'm not making any mistake, because sometimes I make mistakes, but I think I'm doing everything right. It's all multiplication and division, man. So you see that, right? Now I wanna do something. Let me come back quick. Alright, so there are rules of exponent, right? Before I talk about it, that's why I have to write this down. That way I can show you something. I show you something based on the definition I just gave you, okay? I'll show you something, then we'll move on to the rules. Don't forget, man. So let me put it up here. Let's put it up here. A raised to power n is something as a times a times a. Keep going times a. N times, okay? N times. That's what we just said, right? N times. Don't forget that. And then we also said that a raised to power negative n is the same thing as what? It's 1 over a times 1 over a times, keep going, times 1 over a, okay? Again, n times, okay? You keep doing that n times. So keep that in mind before we talk about the rules, okay? This is just definition. By definition, those things they are definition. Understand that, because I'm gonna show you a bunch of stuff, a bunch of mistakes people make, or well, it's not a mistake, but that's how they want to do stuff. I'm not gonna do it that way. I'll show you a better way. Now, let's simplify this based on what we know. Okay, so look at it carefully. You can write that as 6 times 6 times 6, 3 times, okay, over 6 times 6 times 6, 3 times. You see that, right? Now, suppose we want to simplify that. What do we get? 6 cancel 6. 6 cancel 6. 6 cancel. Watch this. It will be 1 over 1. It will be 1. You see that, right? No tricks. 6 will cancel out. I want to show you something. Okay? Now, what of this one here? We'll have 6 times 6 times 6 times 6, 4 times, okay, over 6 times 6 times 6, 3 times. Okay, you cancel that out. You cancel 3 out. Then what do you have? You have 6 over 1, which is 6. You see that, right? Okay, good. We're not playing any tricks. Now I switch it. So suppose do that. You have 6 times 6 times 6. I want you to do that on your own. That way you see it. Then 6 times 6 times 6 times 6, 4 times. We'll cancel this out. We'll cancel this out. 3 cancel out on top. You get 1 over 6. You see that, right? Okay, good. Now check this out. You're gonna see this in rules. Okay? You're gonna see this in rules. Suppose I tell you this is by definition. You just saw it there. There's no magic. I'm not doing any magic. You saw it there. Suppose I tell you that this can be represented as 6. Then you said 3 minus 3. Like that. Raised to power 3 minus 3. And that's the same thing as 6 raised to power 0. You see that, right? You see that? And then so basically what that's saying is 6 raised to power 0 is 1. So keep that in mind. 6 raised to power 0 is 1. So I'm going to explain that. I will explain that in a minute. 6 raised to power 0 is 1. Okay, fine. That's all we'll learn from there. We'll learn that from there. From that one over there. Okay, so let's look at the other one. What is that thing over there? Suppose I tell you, because he has the same, they all have the same base. Okay, he can have different bases, but I put the same base on purpose. We can write that as 6, 4, negative 3. You see that, right? See, raised to power 4 minus 3. You see that, right? Which is the same thing as 6. Same thing as 6 raised to power 1. Which is the same thing as 6. That's what we got over here. You see it, right? Now look at over here. Look at on this one. This one we can write it as 6 3 raised to power 6 raised to power 3 minus 4. You see that, right? And then it's the same thing as 6 raised to power minus 1. You see it, right? And that's the same thing as 1 over 6. Okay, that's what we got here. So I'm not doing any magic. Remember, we defined a raised to power n as 1 over a times 1 over a, keep going, n times, okay? N times. Remember, put it up there, n times, put it up here. So then this one here, 6 raised to power negative n is equals to 1 over 6, one time. The same thing as here. Okay, look at that. 6 raised to power 0. We found it as 1. That's by definition. That's what they call it. Anything raised to power 0 is 1. I hope you see that, man. I can give you more example. And then this one here, you do that, you get that. So, what does all this mean? Why am I telling you all this? Well, this thing is very, very important when you solve problems, man. You gotta know certain things, man. I will show you rules in a minute. You have to know certain things. Basically, when you have, if you have 2 raised to power 3 over 2 raised to power 3, you can write this as 2 because they have the same denominator, the same base. You can write it as 2 raised to power 3 minus 1. Minus 2, sorry. 2 is, I'm sorry. You can write it as 2 raised to power 3 minus 3. That's the same thing as 2 raised to power 0, and it will automatically be 1. I hope you can see that. Why? Well, let's expand that. That will be 2 times 2 times 2, 3 times. What about the one below? 2 times 2 times 2, 3 times. You cross these out. What do you have? You have 1. If you cross all that, I have 1 over 1, which is 1. You see that, right? So, basically, anything raised to power 0 is 1. Alright, so we're gonna get into that. Let me get you what they call rules or laws of exponents, okay? Alright, folks, let's talk about the rules. These are, some people call it rules, some people call it laws. Basically, there are rules that will help you manipulate the exponents when you're solving problems, okay? I kind of feel like if different books they run in different direction. I kind of feel like there are 3, possibly 5 rules, maximum 5. That's it. Maybe let me see, 6. Okay, so this one is called product. This is called product rule. Yes. Okay, this is let me see, quotient rule. Yes. Power rules. Yes, the main power rule is there. Yeah, that's okay, and that's okay too, because you see this one got the same base. This got 2 bases, so it's okay. This got 2 bases, it's okay. Okay. All right. And then as far as I'm concerned, yeah, those are all the rules you need, man. How many of them? 1, 2, 3, 4, 5. Possibly this one 6. This one here 6. So these are 2 different sources. This from a book, and this is from a website. Okay. So I would say there are 5 from here and 1 from here. This one here. Those are all the rules. because you see this guy, this is actually, let me see, that's actually a product rule. That's that one. Okay, this is quotient rule. That's that one. This is what is that? That's power rule. The first power rule here. Okay, so these got two different bases. So that's the second power rule, the third power rule. Okay, so all those are valid. There are 6 of them plus this one. The rest of the stuff they wrote, this is not a rule. Okay, this is not a rule. Those two things can be gotten from definition. This one here is no rule. This one can be gotten from this one. Okay, right? And then this one here, I don't see why that's a rule. That can be gotten from that one. Okay, this one I understand why we can call it a rule. Okay, now this one is no rule. It's from definition. This is no rule. This is no rule. This is no rule. Okay. So the only 5 rules are no. Well, 6. So let me extract them from there. That way you can see. The first one is called product. Okay, it's called product rule. Okay, product rule. And then the second one is called quotient rule. Okay, quotient rule. And then what is the other one? Power rule. Power rule got 3 of them. Okay, power rule, there are 3 of them. Okay, well, let me remove that. That one got 3 of them. And then this thing here is about square root. I like that. That thing is about square root. Okay, this one has A, B, C, and then that one I'll call it let me see, 1, 2, 3, and then let's put 4 here. Let's call it square root rule. I like that. It's you can call that a rule right there. Okay, so everything else can be derived from the definition. Okay, so the power, what is the product rule? It says if all these are m and n and integers, a and b are real numbers. Okay, so product rule says you have a raised to power m times b, the same base raised to power n. Then both of them, if you multiply that out, you will have a the same base. If you see the same base, then you add this. That's all that is saying. It has to be the same base, man. Keep that in mind. And then what is quotient rule? Quotient rule also the same base right here. The same base. Okay, if you have a with m, you have a again with n. So your quotient rule says the same base, then say m minus 1. I'm sorry, m minus n. So that's what that says. You can put bracket there. That way you don't get confused. Put bracket there. Okay. All right. And then power rule. What is power rule? That A, B, C, D. The first one says if you have this is one base multiplied by raised to power m, also times outside the raised to power n, then you can, let me see, you multiply it, product it's power. It says a m times n. If you want, you can put that in bracket if you help you see that. And then the second one, you have 2 bases. This one says base A multiply base B. Okay, and then they have inside there, they have a common they have a common power, and then you separate them. This one gets the power, that one gets the power. That's all that thing says. Okay, and then The number C, it has to do with quotient. Same thing. A over B. Okay, they have the same power. Raised to power M. Then they inherit the power. Okay, that's all that says, man. Then it's A inherits the power, B inherits the power. You see, both of them is similar. You notice that, right? They're similar, see. So okay, so the square root, I like the square root rule. So we took care of that, took care of that, took care of that, took care of that, took care of that. Okay, this one is from definition. I will explain. All these are from definition, man. All these, I'm sorry. This is from definition. This is from definition. This is from the other rules. This from the other rules. Okay. This is from definition. From definition. From definition. Okay. They're not rules, man. They're not. There's nothing like law there. This from definition. But I like the square root one. Okay. Because you gotta pay attention to that. The square root rule. Square root rule says if you have x raised to power, actually there are two parts to it. If you have x, there are two parts to it. I don't want you to get confused. Raised to power 1 over n like that. That's the same thing as x raised to power negative n. Notice that, right? And then you can write that as square root n over x. Okay? You see that, right? That's a rule there. And then you see here, there are two parts to it. Supposing then you have x, instead of 1 over n, you have m over n. Okay, so that's the same thing as, notice the same thing as x, m, negative n. Notice that, right? You see that, right? That's the same thing as square root of n x and then the whole thing multiplied by m. So this is very useful, man. And also that's very useful. So you need to know that. See right there, that's what that says right there. They combine two of them, you see? They combine two of them. You see that? But I broke it up into two parts. That way you need to know both parts. Because if you have that, you can write it like that. If you have that, you can write it like that. If you have that, you can write it like that. If you have that, you can write it like that. That's all that it says. You can exchange it. Okay? So those are all the rules. Let me come back and show you why these are not. That's no rule. That's no rule. And then that's no rule. That's no rule. That's no rule. That's no rule. Okay? I'll come back and show you why I think so. Okay? Alright, folks. So let me show you. That way we can go to a bunch of things. I explained this. This is a rule right here. Okay, I explained that. I said this is a rule. This is a rule, quotient rule. This is a rule. This is a rule. This is a rule. Okay, I said all these are rule except that one. This one is no rule. Okay, these things here are no rule. Let me mark them. These are no rule, no rule. These are no rule, no rule. Okay. I said these are no rules, no unnecessary rules. Those ones. So let me show you. I think I'm showing you some of it. Because when you say x raised to you say x raised to power 1. It's not a rule. We know that. It's x one time. Because if you have x 2, it will be x 2 times 2. I'm sorry. It will be x times 2y, right? Oh man, sorry. Sorry man. It will be x times x. Remember? We talked about that. So I don't know why is that. That's not a rule. Anything raised to power 1 is by itself. We know that. So it's no rule, man. So don't multiply rule there. And then what of this one here? This one says, sorry. That one says if you have You see what it says? If you have x raised to power 0 is 1. It's no rule, man. You get that from definition. See the same thing here. Okay, you get that from definition, man. Because by definition, okay, suppose I have 2 raised to power 2 and 2, another 2 raised to power 2. What do you get? You get 2 times 2 over 2 times 2, yeah? So you cross these out, what do you get? You get 1, right? Because it's 1 over 1 and then 1. Okay, but if we use the, what is that? Suppose I use this rule here. Suppose I use the quotient rule. It has the same, quotient rule has the same power. I mean the same base. That will be 2 minus 2, right? And that will be 2 raised to power 0, which is 1 by definition. You know, that's 1, man. So that's no rule, man. Because you see, we'll cancel out, you will get that. So it's actually from the definition. Don't consider that error, but it's good to know. It's good to know that anything raised to power 0, anything raised to power 0 is 0, except 0. By the way, if you have 0, you raise it to power 0, it's not a 0. It's not 1. It's called undetermined, okay? Just like you remember when we did the vertical line. There's no slope there. Horizontal line, there is a slope. Vertical line, the slope is undetermined. This one is undetermined, man. They say indeterminate. Indeterminate. It cannot be determined, okay? That's all that is saying. You know, so remember that. That has no value. Because we don't know the value, see? Okay. So I'm taking care of that. So I don't know why he called that rule. This is from definition, right? If you have x raised to power negative 1, that's 1 over x by definition. Just like if you have x raised to power 2, that's the same thing as 1 over x times 1 over x. So that stuff is from definition. So that's no rule, okay? So I don't know why they're multiplying all that stuff, you see. So if they define stuff properly, they will see that's no rule. Okay, we took care of that. We took care of all that. Okay. And we already said that's a rule. That's no rule, yeah. Let me show you. That he says x raised to power negative n. We define that. That's negative exponent. You see the same thing as 1 over x times 1 over x. Keep going on n times. So that's from definition. That's negative exponent. So that's no rule. We know that from definition I gave you. That's what I call negative exponent. It's a definition, part of the definition. So we'll knock that out. So we'll knock this one out. Let me see. We'll knock that one out. We'll knock that one out. Yeah. Okay, we said that's a rule. That's a rule. That's a rule. That's a rule. So this one, that one is not a rule. Let me show you. It says a to negative m and then b to negative n. I'm saying you can derive that from this one here. Okay, so it shouldn't be a rule. You can derive it from that one. Alright, so it's not a new rule. You just derive it from that one. Okay, the same thing with this one. You can derive it from this one. Those two can be derived from that one, okay? So I don't know why they're multiplying rules. Because let me show you why. This is that. Okay, let's do that first. That can be written as 1 over a m, okay? Over 1 over a b. It's b n. Okay, we know this from basic arithmetic that can be written as, you can turn it around. Whenever you divide something like that, you turn it around. That becomes 1 over a m times b raised to power n over 1, right? That's the same thing as that's the same thing as keep your eye on the ball, man. That's the same thing as b n, right, over a m, right? See right there. So it's not a rule, man. We'll know that. We'll know that from a simplification. So I don't know. That is taken care of by this thing here. Because that by definition, that is b, by that rule, that is b over a, right? B over a, okay, let me see. No, it's here, right there. So that's b over a. Sorry, you don't need any more stuff. See? You see that, right? So I don't know why they're multiplying rules. That's actually, yeah, that's, yeah. That is taken care of by that rule. So I don't know, by simple algebra. Simple algebra and the idea of dividing, dividing something with 1 over something, okay? So it's not a rule, okay? Now, what of this one? Is that a rule? Well, that one says a over b negative m, okay? I'm saying it's not a rule, man, because you can get that from, let me see, you can also get that from, that's 2, let's see, you can get that from also from here. You can get that from there. You know why? Because you can write that as a over b, okay, over, let me see, like that. You can write it like that. You see? You see that, right? Because a raised to power negative n is the same thing 1 over, you see that, right? So that's what I did here. Okay, so if you write it like that, then it becomes 1 over a m b m, just using this one, using that there. That's what that one says, right? And then, if you divide something with, if you divide anything like that, with, if let's say there's a here, you divide it like that, you have to flip it. That's the same thing here. So if you flip that, what do you get? You get a b m over a m. That's what they say here. Okay? That's what they said there. That's the same thing as b a, like that. You see, that's what they said there, man. So it's not a rule, man. Don't forget about that. You can derive that by knowing how to manipulate stuff. So I don't want you to get confused with a bunch of rules. So these rules I gave you here, they're enough. There are 4 of them. They're enough, man. Then this one is just if you have 2 different bases. So you just study those 4, you should be fine. You don't need any other rules, okay? But anyway, let's leave it there. Next time we'll go to examples. Okay, so let's knock out some examples, okay? Yeah, these are examples. I wrote a couple of them. Then from that we'll go to a higher complexity, okay? Listen, you say just all you gotta do is simplify using everything you know up to this point, including those rules. How many rules? 5 or 6? Just apply whatever you can apply to attack any of these problems, okay? So when you solve a problem, anything you can use to solve it is okay. Okay, so look at that one. If you look at that one, we can probably use the power rule. You remember the power rule? The power rule says 4. That thing is the same thing as 4. What is that? 3 times 2, yeah? It's a 4, 6, right? That's what that says, man. 4 to the power 6, okay? So you just simplify it and leave it. Okay, so what you do, you just simplify, leave it in exponential form. You don't have to try to, get the whole thing. We just want to know you can apply the rules, okay? Look at that one. That one is similar to what we were saying before, right? That one says, okay, so this one basically is same thing as using power rule, okay? Basically, you distribute the power to everything inside, okay, inside the bracket, okay, and then you get 7 raised to power 3 x raised to power 3. That's all. And then we keep going. Look at that one. That is the same thing, okay. So you say -5 raised to power, well, if you yeah, that's nothing to do there. You leave it like that. It's really nothing to do there. Just leave it like that. Actually, no. There's a trick here, because if you multiply this by 4 times, right? If you multiply it, because you see, this is the same thing as -5. I'm sorry, -5, -5, -5, 4 times, right? So if you do that, you can't leave it the way it is. You're gonna end up getting 5 raised to power 4. That's what you're gonna get. Okay, so you can actually leave it like that. But if it's like -5 raised to power 3, then you can leave it. You can certainly leave it, because if after you multiply, you still end up with negative, right? So you can leave it like that. Okay, if it's that. All right. So let's keep going. What is that? We check that out. What is that? That says you have 8 outside. Okay, you have 8 outside, and then you want to multiply. So basically, you see, you apply the rules, you get 8 outside x raised to power 3 y raised to power 3. That's all. You multiply that, you get 8 like that, y like that. That's all. I don't think there's anything else you can do there, So, but anyway, that's what is going on there. You go to the next one. What does that say? Let me see. That's a half inside. I mean, I don't know. What can you really do there? If they don't want you to multiply it out, it's nothing to do there. So basically, you can do that, do to that, okay? Because it's different base. The numerator is base 1, and the denominator is base 2. So you can write that as 1/2 raised to power 3. Okay, that's what they want. You leave it like that. So look at next one. What does that say? That says, yeah, you can do the same thing. Use one of the rules. See, I know how to do this without referring to the rules. You just have to study the rules. Let the rules be part of you. You can write that as x raised to power 3, 4 raised to power 3. You see that, right? That's what they want you to do, man. So now look at this one here. This one is that one is even more. Let me see. That one is a little bit more involved, because you have -2 inside. So what you have to do, you have to go -2 raised to power 3. Okay, x 2. What is that? This times, right? 3, and then y raised to power 3. So if you simplify that, okay, so you're not gonna change nothing with the -2, because it's gonna multiply 3 times. You still end up with negative. So that's gonna be 2 raised to power 3, and that's gonna be what is that? 6. Okay, and that's gonna be 3 raised to power 3. See? So it's not more than that, man. If they want you to simplify it, then -2 raised to power 3 is gonna be -8. But they want you to leave it like that. So if they want you to, I don't know what kind of structure, you can write it like this: 6y3. Okay. All right. So let's find some more examples. All right. So let's do more examples. Okay. The first one is right there. So recall, anything raised to power 0 is 1, except 0. If you raise 0 to 0, It's indeterminate, okay? But this one here will have 1 plus 1 is equals to 2. That's all. There's nothing more to do there, okay? So we'll move on to the next one. What does it say? That one says, so how do you tackle that? Now, don't forget we said that if you have, let me see, yeah, this one is okay. If you have anything like, I know how to solve. If you have anything like this, all right, raised to power negative n, okay? It's the same thing as, you flip it around. Okay, it's the same thing as a raised to power 2, okay? Alright? Because what you do, you flip it around. If you flip it around, it's like we're dividing by 1 over a. So let me make sure you understand what I'm saying. If you have that, a negative 2 is the same thing as 1 divided by 1 over a2, which is the same thing as a2, okay? So the same thing applies here, okay? So this is the same thing as, the whole thing is the same thing as 1, let me see, it's 1 over 6 over 7 all raised to power 2. So if you flip it around, it will be 7 over 6 raised to power 2. That would be 7 raised to power 2 over 6 raised to power 2. You see that, right? That's what that means right there. If you want, you can simplify, but that's what that means, you see. If they want you to simplify, you can simplify. But I think they just want you to leave it unsimplified, okay? Okay, so the next one, it says that there, so it's the same thing. So that thing is the same thing as 1 over 2 over 3, okay, raised to power 3. It's the same thing as 3 over 2 raised to power 3, okay? Same thing as 3 raised to power 3 and 2 raised to power 3. That's all. That's all that says there, man. So that's why I say the rule gotta be part of you. If you know the rule inside out, you shouldn't be having any problem getting all this, okay? So you gotta study the rules carefully. So I'm knowing the rule a long time. So I've been using them a long time. Okay, so what is that one say? Okay, that one says, basically it says minus 4 times minus negative 4 times negative 4 3 times. I'm sorry, you divide that like that. Sorry, 3 times, okay? That's all that says, man. So which you end up where you started, man. You're gonna end up where you started. So that's gonna be, it's actually gonna be, let me see. It's gonna be, let me see. It's gonna be 1 over, the whole thing gonna be negative 4 over 3. It's gonna be like that. The whole thing gonna be negative, man. There's nothing you can do about that one. So that's what you're gonna have. Okay? Alright. So look at this one here. So they want you to evaluate, but don't simplify, like don't make it into big number. Leave it in exponent form. That's all we're doing, okay? So the next one is, what does it say? You see that there, you have to somehow combine that. Those are 2 bases raised to the same exponent. I don't really know what you can do there. Well, I know what you can do. You can say 1 over 5 plus 1 over 3. See that, right? Yeah. So you can combine it. Just combine it. You use our trick. If you use our trick, that would be, the common denominator should be like, that would be like 15. 15 will do it. Or you can use our trick. Remember the trick we use to make it into the same denominator. You multiply. So what you do, you multiply the other one 3. Let me see, 3 over 3 times 1 over 5. Okay, plus 5 over 5. Sorry, 5 over 5 times 1 over 3, okay? If you do that, what do you get? You get 3 over 15 plus 5 over 15. And then you combine those, what do you get? You get 8 over 15. That's all. That's all. That's all you're looking for there. Okay? So let's do the next one. What is that? That thing is, let me see. You see the same thing, man. We just did that. So that's basically, that's equals to 1 over 3 like that. Plus, negative, sorry. Subtract 1 over 2. You see that, right? So that's the same thing as 1 over 3 times 3 is 9. 1 over 9 negative 1 over 2. Right? So to combine those, you can use our trick. How can you turn that into 9? It will be hard to turn 1 over 2 into 9. So basically, you gotta use 18. Okay? You gotta use 18 to combine them. That becomes 2 over 2, 1 over 9. Okay, that turns that into 18 minus is 9 over 9 times 1 over 2. You see what I'm doing, right? So that's the trick. You play that trick, you get 2 over 18 minus 9 over 18, okay? And that will give you, it will give you negative 7 over 18. Okay, that's all you need there, man. We're done. We're done with that one, see? So it's not that difficult, you see. So you just have to keep playing with it until you get it right. Hang on, did I make a mistake? Just give me a minute. No, I think I did it right. So yeah, I did it right. So the next one is, let's look at that one. What is that? I think it's actually the same thing. It just has more fractions. So that one will be 3. Let me see. It will be 3 plus, you flip around, actually 3 over 1 if you want to. You flip the other one around, that will be 3 over 4. Okay, to combine that, you can do 4 over 4, which evaluates to 1, okay? And then you keep going, you get 12 over 4 plus, because you want to get the same denominator, 3 over 4. Keep going, that's 15 over 4. You see that, right? Yeah, it's not that bad. You just have to see it. You see what you're doing, you keep doing it, and then you keep going on. Okay, so let's make it a little bit harder, and we'll knock it out. It's not hard. It's just a bunch of expressions, okay? They add a bunch of expressions to it. You just have to go through it, try to knock it out. Okay, see that one, see what it does? It's nothing there to be scared of. So you go like that, let me see, a raised to power 6. See, the one on the bottom can be written like this, let me see. The one at the bottom can be written like this. Actually, no. Actually, it can be written like, yeah, it can be written like that. Right? Because you can write it like this. Because I will show you. You can write it like that. Because basically what happens is it's like this. is at the bottom. So 1 over a like that. So it's the same thing as 1 over a. So you flip that around, you get a raised to power 4. Do you see that, right? So that's how I got that. So you do that, you get a. See the same. It's the same base. So and you're multiplying. So it's product rule. 6 plus 4. Okay. That's a raised to power 10, not 9, but a raised to power 10. You see that, right? Yeah, make sure you see that, man. Okay, I use that idea here to solve that. Okay, so let's move on to the next one. What does he say? That one is a little bit convoluted. Okay, so that one says, see the same idea, the same idea like we did in the previous one. All right. So what you do there, here is this, write 6 raised to power 4x raised to power 8, see, and then multiply, watch this, 6 raised to power minus 5, okay, and then x raised to power minus 3. You see, I hope you see that. I'm just playing around with it. Okay, look at x and look at, you gotta look at the bases, okay? So it's like this. It's 6 raised to power 4, and then 6 raised to power negative 5. And then you have x raised to power 8 times x raised to power negative 3. I hope you see that. You combine those, what do you get? You get 6 4 times negative 5, and then you have x 8 times negative 3. You see that, right? So you keep going, you get 6 negative, what is that, 20, and then you have x, what did I do? Yeah, negative 24, okay? You see that, right? It's kind of confusing, man, but that's what I got. If you simplify that correctly, that's what I got, man. You gotta simplify that. Wait a minute, did I do it wrong? Actually, I didn't do it wrong. I got it right. But then what happens is, actually, no. Hang on. I think I multiplied it. Sorry. Let's try again. Sorry. Let's try again. I'm not supposed to multiply. See, that's where you gotta understand the rules, man. I kind of have a good idea, but then I messed it up. I multiplied instead of adding. So that would be 6 4x plus negative 5, okay? And then that would be x times x 8 plus negative 3. You see that, right? So if you simplify, that would be 6 negative 1 times x 5. So that's the same thing as, you see that? You see it, right? Something as x raised to power 5 and over 6. You see that, right? I made a mistake before. That's why you gotta know the rules, man. So look, that one is correct. Now let's move on to the next one, because you see I multiplied instead of adding. So we'll move on to the next one. What is that? That's that's the same idea, man. You play around with it. When you need to add. When you need to multiply. Okay. So this is the same thing as 3 raised to power 8 y raised to power 5. Okay, then multiply with 3, the same 3 raised to power negative 10, okay, times y raised to power negative 2. You see what is going on, right? So that's the same thing as, you combine the likes. 3, 8, let me see, 8 negative 10. That's it. 8 plus negative 10, okay? That's what you have here. And then y is 5 negative 2. You see that, right? Make sure you see what I'm doing. You know, you can put bracket there. So it becomes 3 negative, what is that, 2, and y positive 3. So you can also write that as this way. You can write as y raised to the power 3 over 3 raised to the power 2. You see that, right? Make sure you see that, man. That's what I got. You know, so I think I did it right. So let's go to the next one. Next one is, let me see. Next one is the same idea. Try to combine stuff the way you can. It's x raised to the power negative 3, y, see, like raised to the power 1, okay? And then what is that? It's actually 4. And then you have z raised to the power 2. You see that, right? I hope I'm doing it right. Yes. I think I'm doing it right. Is anything? Hang on a minute. Yeah, I think I'm doing it a better. I gotta get rid of that x on top. You do that, you get y, z, like that, and then x to the power 3 multiplied by, you gotta put 4 over here, not on the, hang on, let me clear that, let me clean that up. You gotta put 4, you can put 4 at the back, 4 x raised to the power 3. I think that's it right there. That's what they want. I don't know what else you can do. You know, that's it right there. And then we'll move on to the next one. What is that? What is that? That's see. It's the same idea. So you try to simplify that. There is Q at the bottom. There is Q on the top. There is R. There is P. So you say, you know, you write things in their proper way. So you say, hang on a minute, you say, R over, oh, I'm sorry, R raised to the power 3 over P raised to the power 5 over Q raised to the power 4, like that. And then you have Q, one cube in down there. You have another Q. Let me write it first. So you can simplify that R raised to the power 3, and then you have Q times Q. Basically, you add one more exponent, okay? Remove the other Q. So it's P raised to the power 5, Q, and 5, like that. You know, so that's what I got. I don't know what you got, but that's what I got, man. Q, what is that? Q, did I make a mistake? See, Q is 5, and then P is 5. That's what I got, man. That's what I got. Okay, let's move on to the next one. Let me see. You see the stuff in parentheses, they're the same, right? They're the same. It's A plus B, and then down there is A plus B. So basically you have the same base. So what you do, what you're gonna do, you're gonna say, oh Lord, you're gonna say 1 over A plus B, okay, raised to the power 3, like that. I'm working with that one at top. Then the one on bottom is, actually is A over A plus B raised to the power 4. Okay. See, that one on the bottom is the same idea we used before. Let me show you. If you have something like that, a raised to power negative, like that. So you flip it around, it becomes a squared. That's what we did here. You gotta flip that around, it becomes that. Okay, so what is the whole thing when you simplify? If you simplify, what is that? It's basically a plus b on top 4 over a plus b in the bottom 3. Okay, you see, check this out. It's a plus b, a plus b 4, because it's the same base. 4 minus 3, that's the same thing as a plus b right there. That's the answer, man. That's the answer. Okay, so let's move on to the next one. What is that? What is that one? That says, I think it's the same thing. They make it a little complex, but it's the same base. Okay, so don't get confused. It's the same base. We're gonna use this principle there, that principle there. So that's the same thing as we start with the numerator. It's 1 over x plus y raised to the power 8. You see that, right? That's what that says by definition. Okay, and then you multiply it by x plus y raised to the power 9. We use that principle there. Okay, so you keep going. What is that? Well, let's come over here. What is that? It's x plus y raised to the power 9 over x plus y raised to the power 8. So you see the same base. So basically you say x plus y, okay, 9 minus 8. You see that, right? I hope you see that, man. X plus y, that's it. That's nothing else, raised to the power 1. Because once you subtract, that's what happens. So I see, the skill you get here will be very, very valuable when you do calculus, okay? Basically calculus has rules. Once you follow the rules, everything will break down to fraction. You should be able, not fraction, but algebra. You should be able to manipulate the algebra, okay? That's what happens in calculus. You know how to manipulate the algebra, then you don't have a lot of problem. Okay, so let's deal with the next one. I think it's the same idea. The next one is the same idea. Let me see. I hope I have enough space to finish them. The next one is the same idea. Let me stare at it. Yeah, it's the same idea. So, see, it has the same base. You see the same base inside the bracket. So you say, start with the numerator. You say x plus 2y. That's why I say you gotta spend time. The initial stuff I said during this video, on make sure you understand what is going on there. This is the same thing as let me see. Hang on a minute. Is it the same thing? What did I do? I'm sorry. 1 over this is 3, okay? Times what is that? X, the same base, 2y times raised to the power 5. You see that, right? So you go like that, x plus 2y raised to the power 5 on top over x plus 2y raised to the power 3. Okay, see, the same base. So you have x plus 2y, alright? 5 minus 3. See what I said? You gotta know how to do all that. You know how to manipulate stuff, you okay. That becomes x plus 2y raised, because that is 2 raised to the power 2. You see it there, right? That's what is going on there, man. So keep your eyes on the ball, man. The same thing with that one. It's the same thing. See, it has the same base. Look inside the bracket. The same base. So you say equals to p minus 3q, okay, over 1 raised to the power 2 times, the whole thing times p minus 3q raised to the power 4. Okay, so make sure you understand this. I'm using this idea here. So what do? You go equals to, becomes p minus 3q. This one becomes the numerator, 4 over p minus 3q 2. You see that, right? It becomes p minus 3q, okay, 4 minus 2. You see that, right? Becomes p minus 3q, okay, all raised to the power 2. Make sure you see that, So go back here and follow me slowly until you know what I'm doing. If you know what you're doing and pay attention, it's not that difficult, man. It's just a bunch of variables. All right, we'll have another batch, okay? You are asked to simplify. Yeah, we'll just simplify, okay? Using everything we know. Everything we learn so far. All right? And we'll have learned a lot. So what is that? That's equals to, let me see, 6x raised to the power 4. You can write it like this, 6s over 3. See that, right? Always want to write it the way you can then apply the rule, see? Because it's the same base. You see that 6s is the base, so 4 minus 3. See that? It's 6x. 6x, let's see, 6x raised to the power 1, which is 6s. That's all you got there, man. So that one is knocked out. Okay, so let's go to the next one. What is the next one? Is let's see. That one is see that there. I want to make sure I wrote it right. Yeah, I did. So let's attack that. The same idea. So you write it. Notice that when you simplify, it has the same base on the top and on the bottom. You just have to write it the way, simplify the way you can see it. That's all. So that's equals to, let me see, 1 over m raised to the power 7n times, all right, let me see, that is, let me see, just give me a minute. That is m raised to the power 4 over, let me see, that's, actually no, I can write it, remove that, I can write it as m times n raised to the power negative that. You see that, right? So that's the same thing as m raised to the power 4 n raised to the power negative 3 over m raised to the power 7 and then n over here. You see that, right? Notice that m can cross out. Notice that we can do m is m, let me see, 4 subtract 7, okay, and then we can do n, see, we can do n negative 3 plus negative 1. I think so. Let's see if we work out. You got m negative 3 and negative 4. You see that, right? That's the same thing as, I don't know if we can do more. That's the same thing as 1 over m3 times 1 over n raised to the power 4. See that, right? The same thing as 1 over m3 n raised to the power. When I say n3 means n, m3 means m raised to the power 3. That's what I'm trying to say. See, I think that's the answer right there, man. Yeah, that's the answer right there. I don't see where I made mistake. You see, so so let's move on to the next one. The next one is we did that. The next one is this one there. All right. It's see the same idea. Okay, simplify. How do you simplify that? That is notice it's different base inside that bracket, so we can apply the rule that say if you have that, then you can multiply the stuff out. Okay, so we'll say m let's see, negative 8 times times 2 and negative 4 times 2, okay, over m2 raised to power second and n raised to power 5. You simplify that, what do you get? M raised to power 6 negative 16 and raised to power negative 8 over m raised to power 2 and raised to power 5. You see that, right? Okay, so you keep going. You see, you can combine the m on top and the m on bottom, the n on top and the n on the bottom. If you do that, you get m negative 16, okay, subtract 2, okay, and then n negative 8 subtract 5. You see that, right? Okay, you do that, you get m negative 18 and the n negative let me see, 13. I think we did it right. Let's see what we, yeah, let me see if I made a mistake anywhere. But we can put it in, let me see. Yeah, notice that that's the same thing as 1 over m raised to power 18, okay, all over multiply by n raised to power 13. You see that, right? That's the same thing. You can either write it in that form, or I think it's better to write it in this form, okay? Alright, so we're done with that. We did a good job there. Let's move on to the next one. What does the next one say? That one is also a lot of writing. Alright, so we just have to write it out and then simplify, okay, because the denominator and the numerator has the same, the bases are the same. So this is let me see, first you remove the brackets, okay, you have x negative 1 times negative 2, okay, and then you have y 2 times negative 2, okay, and then you have z, it becomes negative 2 with a power of negative 2, and then you have x, let me see, I think, well, I will work it out, negative 3 times negative 1, okay, y 3 times negative 1, z negative 1. Okay, so you simplify that, what do you get? You get x on top positive 2, y negative 4, z negative 2 over x positive 3, y negative 3, z negative 1. You see that, right? So then you can do the trick. You start using some kind of the rule, one of those rules. That's why I say you gotta understand the rules inside out. I know those rules inside out, even though I'm not gonna tell you which rule I use. I know how to use them in practice, okay? So this becomes x, let me see, because I'm trying to combine that, okay? It becomes x like that, raise to power that minus 3 from the bottom there, okay? I'm sorry, not x, y, sorry. Y negative 4 minus, what is that y below is, let me see, minus negative 3. And then you have z negative 2 minus negative 1. You see that, right? So keep going. What is that? You get x negative 1 y. Okay, negative. See, negative. You see the thing in bracket over the negative subtract negative. It's like over here. It's like you have 1 here. Negative 1 times negative 3. So make sure you understand that. So if you do that, you're gonna have it becomes positive, and then you get 1 negative 1. You see that, right? Because positive 3 minus 4. That's what you get. You get minus 1. Okay, when you go to z, what is z? Negative. Okay, that one becomes positive there. It becomes positive 1 because it's negative 1 times negative 1. So then you have negative 1 there. Make sure you understand that. That's negative 1. Let me see. Just give me a minute. That's yeah, that's negative 1 there, okay? Alright, so you keep going, you simplify it, it will be 1 x, y, and z. You see that? Yeah. So that's the answer right there, man. That's the answer right there. You see it? That's the answer right there. So you have to be able to see things. Be patient, keep going, you see things, right? You just knock it out. Okay, look at this one. It's a little bit still more complicated, but if you really understand what you're doing, it's not that complicated, man. You just follow the rules, apply what you know, and keep going, you get it right. So that one is, I'm 100% sure is right. So let's do this one here. This is, we got plenty of space to knock it out. This one is the same thing as, remember the rule when you multiply. There's a rule that says, remember, I forgot let me go back to the rules. I'll show you. Let me go back and show you the rules again. Let's go back. Where are the rules? See the rules here. When you have something like this, you add. But when you have something in the bracket like this, that's power rule, okay? You see that, right? This is power rule here. This is over here is also kind of power rule. But this is quotient rule. We use that a lot. So the only time you add is if you have the same base. And then if you have the same base when you're doing quotient, you subtract. I use that a lot. But here you have to multiply. Here you have to, you have to, let me see. On this one here, you have to actually, you distribute that. Okay, so let's go with that. Let's go back and finish our stuff down here, and then we'll move on to the next set. You see that there? All right. So what is going on there? You see, you gotta distribute that minus 4 inside. Distribute minus 5 inside that bracket. So you get A 2, all right, 2 times minus 4, B 3 times minus 4, C 4 times minus 4. You see that, right? Okay. So you do the same thing in the denominator. You get a minus 2 times minus 5, b minus 3 times minus 5, okay? And then c minus 4 times minus 5. See that, right? Okay, so you simplify all that. What do you get? Start multiplying things. What do you get? You get a in the numerator, a negative 8 times b negative 12 times c negative 16. You see that, right? Okay, in the bottom, you see, you got a negative positive 10. So you got 10, not negative 10. And then you got c positive 10. What is that? 15. And then you got, oh, no, that's b, sorry. See? That's b. That's b right there. Then c positive, what is that? Positive 20. You see that, right? I think we're on the right track. Okay, so if you simplify that, remember you can combine this, combine that using the quotient rule, okay? Alright, so you get a minus 8 minus 10. You see that, right? Minus 10. Actually, I gotta make more space. I gotta be careful because I run out of space. A minus, let me see, 8 minus 10, okay? B minus 12, let me see, minus 15. C minus 16 minus 20. You see that, right? So you simplify, you get a minus 18, b minus 27, c minus, what is that in there? It's a 36. I think that's it, but we can write it this way. Let's write it this way. You get 1 over a raised to the power 18 times b raised to the power 27 times c raised to the power 36. You can write it like that. Okay? So you see that, right? Yep. You see it. I don't see any mistake we made. You just follow the rules. You're gonna be okay. Okay, so we're gonna, do next batch. Alright. So let's deal with this batch. You see that there? So you gotta simplify that. So you be careful. Remember the rule that says if you have let me see, you have a over b. What is that quotient rule? And you have that. You have to distribute it m, and then b inherits power m. Okay, so that's what we're really going on this one. So let's distribute that. What do we get? Numerator and denominator, we get x negative 3. Okay, y, what is that? Y negative 2. Then you distribute that negative 3, okay? Yeah. Over, let me see, x 2, you distribute that negative 3, y, negative 3, okay? So you keep going. What is that? If you do that, you get x negative to power negative 3, and then y. You multiply that out, it becomes positive 6. Okay, what is the other one? You say you multiply that out, it becomes x raised to the power negative 6. Alright, and then of course you have y negative 3. You see that, right? Okay, so you gotta simplify that. When you simplify that, what do you got? You simplify that, that's negative 3 there. Okay, sorry. You simplify that, what do you have? Okay. Basically, you have, see, combine x. What am I doing, man? You're gonna combine x with x, y with y. You get x, negative 3, subtract negative 6. Let me see. No, subtract. Yeah, you have to make sure you do it right. Subtract, and let me see. You subtract negative 6, okay, and then y 6 is subtract negative 3. See that, right? So you simplify that. Let's do it over here. You get x. This is it's like negative 1 times 6. So this would be, that's positive 6. Okay, so that would be 3. No, 3. What is 6 minus 3? 6 minus 3 is 3, yes. And then y, 6, let me see, 6 plus 3, because that becomes positive 3 there. It will be 9. I don't know if I did that right, man. Let me check it. Hang on a minute. See if I did anything wrong. Go from here, go there. This one is kind of a little, I think I did it right. Okay. Okay, so let's do the next one. You see the next one there is a little convoluted, but we can do it. We can also tackle that. You see, we'll tackle it. What is that? I hope you've seen everything. I think I'm getting out of. Let me put it down a little bit. That way you can see everything. All right. So that one is the same thing. So we'll start simplifying. It's a 2 negative 4 raised to power negative 4 arrow raised to power negative 4. Okay. 2 raised to power 5 arrow raised to power 5. You see what I'm doing, right? And then here 2 raised to power 9 arrow raised to power 9. 2 raised to power negative 7 arrow raised to power negative 7. Okay, you see that, right? I'm just doing it slowly and doing everything right. So notice that 2 can combine to arrow, combine arrow, then 2 also combine to, see, 2 combine to the arrow, combine arrow, 2 combine to arrow, combine arrow. Let's do it that way. So when you do that, yeah, you gotta be careful, man, because a little mistake now, it throws everything off. Let me see. Can you cancel? Yeah, you don't want to start canceling because then you make mistake. So let's do it this way using the rule: 2 raised to power 4 minus, I'm dealing with this 2 here, minus 9, okay? And then r raised to power 4, negative 4 minus 9, okay? All right. 2 raised to power 5 minus minus becomes plus 7, okay? Let's just combine that. Then r raised to power 5 minus minus 7 becomes plus 7, okay? Okay, so we do that. What do we get? We get 2 raised to power 13. I mean negative 13, okay? R raised to power negative, another negative 13. and then 2, another negative, what is that, 12, and then r, another negative 12, you see. Okay, so basically let's combine like terms. You say 2 negative 13, okay, plus 2 power of 12, and then we'll combine r negative power of negative 13, and then r negative 13, and also positive 12, sorry, positive 12, I'm sorry. Okay, so you combine that, so it's a question of adding them. When you multiply, you add them. That's power rule. So that's this one here. It becomes 2 raised to power negative 1 times r. This one here becomes negative 1. You see that, right? Hey, I'm going over to the other side, man. So that would be the same thing as 1 over 2r. You see that, right? I think I did it right. I think I did it right, man. I think I did it right. I don't see any mistake I made. I think I went over too far, you know. But let's see if we can squeeze that in there. Okay, so we'll do the next one. What is that? That's gonna take a lot of space too. They're taking more spaces, man. These things are taking more spaces, man. You know, because it takes a long time to deal with them. Alright, so let's deal with that. That one looks simple because you look at inside the bracket. They all have the same, it's all the same, what do you call that, the same base. So we'll say it's equals to, you see that, right? It's the same base, 8x. So that one shouldn't be hard, because you just combine stuff, man. Combine stuff on top, combine stuff on the bottom. What do you have? You have, let me see. You have 8x on top minus 8 plus 9. And then 8x on the bottom. Okay. 13 minus 11. You see that, right? So that one is not that difficult. So 8x, what is that combined in there? It's just 1. You leave it like that. And then what is that one? That's also 1. No, not 1. 8x 2. You see it, right? So then you can say 8x, okay, 1 minus 2. It becomes 8x minus 1, which is the same thing as 1 over 8x. That one is not difficult, man. That one was easy. Okay. You just have to be careful what you're doing, you know. I think I did it right. Look at it carefully. I don't see anything. Sometimes I make mistake, but I don't think I made mistake there. Okay, look at the next one. Next one is a bunch of stuff, man. Yeah, next one is a bunch of stuff. Let's see. Oh, man. Next one is just a bunch of stuff. If you look at it carefully. Actually, it's like the other one. Look inside the bracket. They're all negative 9p. So all you gotta do is start combining stuff. You see it, right? Look at what is inside the bracket, man. They're all negative 9p. So all you gotta do is start combining stuff. So you combine stuff on top, on the numerator, combine stuff on the denominator. What do you get? You get negative 9p, okay? It looks confusing, but if you see clearly what is inside the bracket, you see they're all the same. You can replace negative 9p with the x. You see? But we don't want to do that because we get confused. You combine that, what do you get? Let me see. You get, what is this? It's 16 minus 16. That's 0. Okay, so let's see how it turns out. Negative 9p what is that? It's negative 41 plus 42. So the top is 0, so that's 1. Okay, and then what is this? Is negative 9p. What is that? It's actually 1. So that one is turning out to be simple, man. It's 1 over negative 9p, man. I don't know if you see that. Did I make any mistake? Yeah, that one is easy, man. That one is really not because you see here, you get let me see, you get negative. Now I hope you see that negative 9p over 0, which turns out to be 1. See that, right? 1 over negative 9p. Okay, you see that, right? And then that's what we'll have here. You can write it as a negative 1 over 9p. You can write it like that if it makes you feel better. But we're done with that, man. So let's move on to the next one. Hopefully this one will be, I think this one will be, look at inside the bracket. Everything is the same base. Inside bracket is the same thing. So you can replace that with A if you wanted to. So we'll do the same thing. We'll start combining things in the numerator, combining things in the denominator. You get negative 4y. Okay, 8 minus 8. Oh, that turns out to be 0 again. You see that? Negative 4y is negative 26 plus 27. Yeah, it's easy if you can see it clearly. That becomes negative, let me write it out, negative 4y raised to power 0 and negative 4y, what's that, raised to power 1. What is that? That's 1 over negative 4y. Check it out. I don't think we did anything wrong, man. I think we did it right. You know, you gotta check it out. Yeah, check it out and see, man. We did it right, man. We didn't do anything wrong. We did it okay. You see? I don't see any way I made mistake. Look at it carefully. If you look at it, it's confusing the initial problem, but when you realize it's all the same base, it's all the same base in there. See, inside the bracket, then you know it's not a very difficult problem. You see. So let's go to the next batch. All right. Yeah, let's do the next batch. Now, this one is getting harder and harder. You know, the ones with the previous three we did, if you look at it carefully, they had the same base. But this one seems to have a different, it's actually the same base, but then inside the bracket it has different things that make the base, has different things combined with it. Look at that, one of them times 4, one of them times 2, and then another one raised to power 2, 3, and so on. So let's knock it out. We just go slowly, try to combine things, okay? All right. So what is that there? We'll have let me see. What is that? We'll have let's see. We'll have let's see, we'll have 4 raised to power negative 2, a raised to power 2 times, let me see, it should be, 2 times minus 2 is minus 4, okay? And then b, 3 times minus 2 is minus 6, okay? And then we'll have the other side. Where is that? Okay, 2 raised to power 3. Then you have a raised to power 3, b raised to power negative 3. You see that, right? And then what is on the bottom? A raised to power negative 12, b raised to power negative 4. You see it, right? Anything can cancel out. We don't know yet. That one is a little more complicated, man. Yeah, this one is a little bit a little more complicated. I can see what to combine there and what not to combine. Let me see. 4. Notice something. I can see something. Notice that 4 on top can be written as 2 raised to power. What is that? Raised to power negative 4. You see that, right? Right, then a raised to power 4, b raised to power 6. Okay, and then 2 raised to power 3, a raised to power 3, b raised to power negative 3. You see it, right? Okay, so that will help us see something. 8 raised to power negative 2, b raised to power negative 4. Okay, so now that we basically, we still gotta deal with the bracket. So if we combine the stuff inside the bracket, what do we get? Oh my god, I'm gonna run out of space. We'll get 2 and 2 has the same base, so that would be 2 negative, because if you multiply them, it's a product, right? So it has to be, you have to add it, so it's negative 1. See, now we're dealing with product of stuff, right? A raised to power 4 times a raised to power 3. It's a product, so it's a negative 1, okay? And then b and b, it will be b raised to power, what is that, 9, because you add those, okay? And then what of the denominator? You put that there in 12b negative 4. And then now you can combine denominator and numerator. You have 2 negative 1. A go with a, b go with b. You have a negative 1 minus negative 12 becomes plus negative 12. You see that, right? And then b negative 9 minus negative minus negative 4. It becomes positive 4, so it becomes plus 4. You see that, right? And then 2 negative 1 becomes, you simplify what is on a. You have a, let's see, a11b negative 5. You see that, right? So you can write that as this. I think we did a good job. We can write that as this. A raised to power 11 over 2b raised to power 5, like that. I think we did it, man. I think we did it. I don't see anything. Let me see if we made any mistake. I don't think so, because it's quite torturous, but I kept my cool, get all that done. Okay, so let's do the next one. I don't really know if we'll have a lot of space. I might have to move this one down, because let me move this down a little bit. Just give me a minute. All right, let's deal with the other one. I had to make a little space, so we'll have more space to work with. Okay, notice what is going on there, man. You have to be patient and do it slowly. Don't be in a hurry. If you be in a hurry, you're gonna make a mistake. That one is actually very long. How do you attack this? How do you attack this, man? Okay, it's okay. Notice what is inside the bracket. They are different, okay? So you start with the removing bracket. You have 2 raised to power 2y If you remove bracket, you have to multiply. Negative 2z 4. Okay. And then the other bracket is 3 raised to power 3 y raised to power 6 z raised to power 9. Okay. All right. You put back the bracket on the bottom. It's y 3 z 2 and negative 1. Okay. We didn't quite remove the bracket because we can't. Let me see. So we keep going. What is that? I see they have the same thing. So you can actually remove the bracket and combine like terms. You see, you combine that with that, and then combine that with that. You see that, right? Okay. So let's remove the bracket. We'll have 2 times 2 raised to power 2 times 3 raised to power 3, okay? And then multiply with, what is y? Combine y with y, you have a y raised to power, if you multiply, you have to add. It's negative 2, negative 2, negative 6, okay? It's negative 2 plus negative 6, so you write it like that. Z is positive 4, so it's like this 4 negative 6 minus negative 9. Okay, and then remember what is on the bottom. You can even multiply that one out. What do you have there? You have y negative 3 z negative 2. Okay, so you keep going. Let's come up to this one, that way we'll have space. Alright, what you get there, what do you get there, man? I don't want to mess up, just clean it now. Okay, this is right there. Alright, so what you do there, you can say, basically you can multiply that out. What is that, man? That's 4 times 9. What is 4 times 9? 4 times 9 is 36, and then I will say, I'm gonna try to combine. Well, let's simplify first. You have y negative, what is that, 8, and z negative 5, okay, over y negative 3, z negative 2. So you combine this with this. What do you get? You get 36. Okay, y is 8 minus 8 minus it becomes minus 8 plus 3, okay? And then z minus 5 minus 2, it becomes minus 5 plus 2. Okay, 36 y negative 5 z negative, what is that? Negative 3. So you can write it as 36 over y raised to power 5 z raised to power 3. I have a feeling that we messed up somewhere. I don't know why I'm having that feeling. Yeah, I have a feeling we messed up. You know, there's something we left out. We left out something. This is a long one, man. We left out something somewhere. Let me see. We left out something somewhere. I don't know what it is. But I think we did it right. You know, I think we did it right. What is that? Oh, right here. I made a mistake in my multiplication. I see it. I have a feeling some. Sorry about that. I paused. I forgot I paused. So what would I caught the mistake here? I caught the mistake there. I did 3 raised to power 2 instead of raised to power 3. So 3 times 3 times 3 is 27. 27 times 4 is 108. You see, I cleaned that up. 108 and then 108. That's me. I had a feeling there was a mistake. So I cleaned that up. So let's do the next one, okay? Okay, I went ahead and created more space for the next problem. You see that right there? So how do we tackle that? How do we tackle that? So that's the same thing. You notice that if you look at it carefully, there's nothing in common there. So you just have to start, simplifying things, okay? First, you remove the bracket on top, remove the bracket on the bottom. What do you get? To remove the bracket on top, let me see. It's gonna take, it's actually gonna take 2 steps. So we do, let me see, we do 9. Remember, let me show you the rule we're gonna use. When you remove that bracket, let's go back to the rule. That way you understand what I'm doing. Where is that? Where are the rules? I want you to understand what I'm doing. Let me see if I can find the rules right here. Hang on, okay, here is the rule we're gonna use. If you remove the bracket, okay, look at that one right there. If you remove the bracket, you multiply. You multiply what is what is raised to the bracket with what is raised to a. So you remove that. So you always gotta be careful. You see this rule here. That's not the one we're using. We're gonna use this one here to remove the bracket. Okay. All right. Okay. So we'll do. If we remove the bracket, we'll multiply those. We get 9 because -1 times -1 is 1. So you can put it right there. And then z, -1 times 2, -2, you get 2. X, -1 times 1 is there, is just -1, okay? All right. The power is -1. Okay, so you do the same thing on the other bracket. All right, so 4 has 1 on top. Well, you can say 4, -2, and then z, -4. You see it, right? We're multiplying things out, and then that's -8 right there. You see that, right? Okay, so we'll do the same thing on the bottom. 5. It's 1 there, so it's negative. It's +2. Z is positive. Let me see. -4. Okay. X is -6. You see that we're multiplying things out. That's what we got there. So let's simplify. We'll simplify some stuff. So how do you do that? We can remove the bracket, okay? We remove the bracket on top. What do we get? Let's remove it. We got plenty of space to work this problem, so let's take as much time as we need. We remove that bracket, so we'll have 9 times 4, -2, and then we'll have z. Now when you multiply two things like that, you're adding, okay? You're adding it. So z become 2. The power in z right here is 2. The power in z here is -1. So you add it, you get -2, okay? And then x, you got negative here, you add it, you get -9. I think I'm doing it right. That so then you do 5 raised to power 2 z negative that x negative that. Okay. So you see that, right? So we can basically take care of this, and then we can take care of this, and we can take care of this. You see that, right? That's all we gotta do now. Notice that. Let's take care of the numbers first. You notice how I write it. This is 9 because this is negative here. It's 9 over 4 raised to power 2, and then this is on the bottom 2. So it would be like that. So let's simplify that first. It would be 9. What is that? If you take care of that, it's 4 times 4 is 16. 16 times 5 times 5 is 25. Okay, 16 times 25 is 400. So we got that. That boils down to, let me clean that up. So it boils down to 9 over 400, okay? Sorry, 9 over 400. That's what that boils down to. Okay? So let's, I want you to see that. Let's clean it out. It's 9 over 400, okay? I mean, if you want, let's keep going, man. We're writing, we're writing 9 over 4, okay, times, 4 times 4, 5. This is times 5 times 2, okay? So we know what that will be. I mean, we want to do it cleanly. And then this one here, we take care of this 2 here. What do we get? We get z minus 2 minus 4. It becomes plus 4, okay? X on top minus 9 minus 6, it becomes plus 6. Okay, that's what we got there. So we keep going. What is that? Remember we got 9 over 400, okay? And then z, we simplify z. What is that? It's 2. We simplify x. What is that? It's negative, negative 3. So you can write that. You can write the whole thing like this. You can write 9 times z to power 2 over 400. Let's see, 400x raised to power 3. You see that, right? That's what I got, man. That's what I got. So I think we did it right. So we're done with that one, man. We'll move on to the next one. Okay, this is the next one. Let's attack this. Okay. Look at it carefully, eyeball it. Where do we attack from, you see? You see that? We don't see, everything is different, so we're gonna have to start doing what we know how to do. That's all we can do. Anyway, let's remove the bracket, okay? When you remove the bracket, what happens? You have to multiply, okay? So you say x 6, let me see, 6 times minus 2 is minus 12, okay? And then y, it becomes minus 2. Alright, well, we can't quite remove brackets. We'll just take care of that then. It's x raised to power 2 times 3 is 6. I'm sorry, y raised to power minus 2 times 3 is minus 6. You see that, right? And then down here is x negative 1, y negative 2. So we keep going. Now we multiply the 2 brackets. Now we will have to add things, okay? X minus 12 plus 6, and then times y minus 2 minus 6. over x minus 1 y minus 2. You simplify the numerator. What do you get? You get x minus 6 times y minus what is that, minus 8, okay, over x minus rest of power. When I said that, you know what I'm saying. Okay, sorry about that, man. All right, I'm thinking out loud, that's why. Now see what we can do. We can combine these two, combine that two, and then we're done. So how do you do that? You say x raised to power negative 6 to combine with x in the denominator. What you have to do, you say minus 1. You see that, right? Times y minus 8. To combine with this y here, you say minus 2. We're using the rule. So you keep going. What is that? You simplify. It will be x. I always tell you, when you do that, you see, it's like you multiply negative 1 times negative 1. Okay, so it's gonna be negative 5, okay? Because it's negative 6 plus 1. Okay, the same thing with y. This is negative 1 times negative 2. So if you say plus 2 add to negative 8, you get negative 6. I'm sorry, negative 6. I don't want to write with red pen. Sorry about that. It's negative. Oh, what the hell? Sorry. It's negative 6, okay? All right. Okay, so did I do anything wrong? I don't think so, man. You can write it like this. It's 1 over x raised to power 5, y raised to power 6. Let me see. I think we did it right, man. I believe we did it right. We did everything right. Yeah, we did everything right, so that's what we're looking for. So let's move on to the next problem. This is the next problem there. We'll knock it out. We'll knock that out, and then let me see. All right, let's eyeball that. Now, everything is different, man. Well, the same thing are inside the bracket, but they multiply with 3 and they multiply with 5. So we just have to do what we did before. We'll go slowly, knock things out. So we'll do equals to, first we'll remove the brackets, okay? You remove the brackets, you raise to power, okay? It's power times power. You have 3 times 2, raised to power 2, and then p raised to power negative 4, okay? And q raised to power 6. You see that, right? And then you do the same thing. 5, negative 1, p is 1 there, q is 4 there. Okay, just keep going. And then you do the same thing that on the denominator. You have p raised to power negative 6, q raised to power positive 6, because negative 2 times negative 3, see? So we keep going. What is that? Okay, so we remove bracket on top. What do we get? Basically, to remove bracket, we have to combine stuff. Combine that with that, and then combine that with that, combine that with that, okay? So let's do that. If we do that, we'll have, basically we'll have 3 raised to power 2 over 5 times p negative 4 plus 1, which is negative 3, okay? And then q 6 raised to power 6, and then the other power is 10 raised to power 10, because we're adding now, okay? So that's the stuff on top. Okay. So that's the stuff on top. We don't want to get confused. We can write this like this. Actually, let me see. Just give me a minute. Let me think now. We don't want to make mistake. Okay. Notice that we can write. Well, let's write this like this. What is that? P raised to power negative 6 Q raised to power 6. Notice that we can write this that we'll remove. What is that? 9. 3 times 3 is 9 over 5. We can write that like that. And then we're dealing with P raised to power negative 3Q raised to power 10. Yeah, we can write it like this. It's the same thing. P raised to power 6Q raised to power 6. See? And then we'll simplify P and Q. We'll get 9 over 5. Okay, P negative 3 on top. From the bottom you get negative 6. Okay, multiply by Q, 10 on top, negative 6, like that. See? So that's the same thing as 9 over 5. Okay, then P, whenever you have negative, that's, that's it's like negative 1 times negative 6. So you have, that becomes positive. So you have it becomes 3 over here, and then here it becomes let's see, 4. You see that, right? I think we are done, man. I think we are done. So we're done. That's all we're looking for. If you want, you can write it as P. Well, sorry, you can write it as this. So it's up to you, man. But we're done. There's nothing else to do. You can say 9P raised to power 3 Q raised to power 4 all over 5. You can write it like that if that makes you happy. But we're done with that. So let's do this is gonna be my last one, man, please. Because we need to rest. So let's do this one. What is that? Yeah, we'll knock that out quick. That doesn't look all that difficult. Let me see. It doesn't look all that difficult, but do we see any pattern? No. Yeah, no. It's the same thing. We'll just work from the bracket. Remove the bracket. Okay, so we'll remove the bracket on top, the bracket on the bottom. Alright, then we'll have so when you remove the bracket, you multiply the coefficient. I mean the powers. Right? When you remove the bracket, you multiply the powers. When you don't removing the bracket, then you adding the powers. I will say it when we're doing it. Now according to the rules, right? I think it's the quotient rule. Now we'll have to what is that? Is it the quotient rule? Let me pull it up for you. That way you see what I'm saying. Alright, it's actually the power rule. You see, yeah, it's the first power rule. When you remove the bracket, you multiply things out. You multiply the power with power, okay? Alright, so that's what we'll do first, to remove the bracket. After that, then we apply this rule. Let me see. After that, we apply, where is that rule? We basically apply this rule here, product rule. So when you multiply two things with the same base, you multiply them out, you add them up, okay? Okay, so let's apply the first power rule. You get 4 times minus, 4 raised to power minus 2 times raised to power. See that power in the bracket? If you multiply that, you get 2. Okay, x, you multiply that thing with the bracket, you get 2. And then y, you multiply, you get 4. You see that, right? So I just did the first bracket. Let's do the second one. you multiply that, then it's like there's 1 here. You get 5 raised to the power negative 2. And then x multiply it, you get raised to the power 6. And y raised to the power negative 8, okay? And then you do the same thing there. You multiply out, you get to, it's like there's 1 here. You get to 3 raised to the power 2 x raised to the power negative 6 y raised to the power negative 10. Okay, you see that, right? So we'll keep going. So we'll have to remove, let me see. We'll remove the bracket again. This time we apply the product rule, okay, where you add stuff up. So if you combine that and that, because you're multiplying them, you add that thing up. So it will be, but you gotta be, let me think now. Is it the same? No, we can't do that because it's not the same base. So basically what we have to do, 4 raised to the power 2 times 5 raised to the power negative 2. Because they don't have the same base. You do that with the same base. Okay, x, right? X times x. Those are the same base, right? Then you have 2 plus 6. You see what I'm doing, right? And then you have y, 4, you add minus 8. You see it, right? And then you write what is down there. It's 3 raised to the power 2 x raised to the power negative 6 y raised to the power negative 10. You see that, right? Okay, so we can take care of this, and then we'll take care of this, and we'll take care of that. So it breaks into 3 parts. So take care of the numbers. What is that? Okay, notice what is going on with the numbers. Okay, 4 times 4 is 16. And then this is the same thing as 5 raised to the power negative 2. It's the same thing. Let me clear that. That way you see how I got that. Oh, man. You bring that down. It's the same thing as 5 like that. Okay, so that's what you have to do. So it becomes 16 over, what is that, 25 times 9, and it becomes 16 over 225. You see that, right? It's 16 over 225. So let's clear that. We'll combine that. I showed you how I got it. So it becomes 16 over 225, okay? All right. So once we get that, let's deal with the other stuff. Let's deal with this. What is that? That's actually, let me see. The stuff on there is 8. So it's x. Okay, x 8 minus, what is that? Let me see. Minus, yes. Minus 6, okay? Alright, because that one is on the bottom. The x with the power of negative 6 is on the bottom. And then we'll do the same thing with y. If you add those up, you have negative 2. Negative 4. And then you bring this one up. The one on the bottom you have is minus negative 10. You see that, right? Simplify. 16 over 225 is x. I always tell you, if you multiply, it's like you multiply negative 1 times 6. What do you have there is 8 plus 6. I hope I'm doing that right. Oh, wait a minute. I see a mistake. This is not x. That's y. See, sorry, that's y here, not x. Okay, so you do that, then you do the same thing with y. what is that? There is negative 4, because this is like negative 1 times negative 10, okay? So you get plus 10. So you then say 16 over 2 to 5x raised to power, what is that, 14, and y raised to power 6. I think I'm done, man. You see that, right? I'm done. X raised to power 14, b raised to power 6. I think we did it right. So I think I'm tired today. So please subscribe to my channel, like and share this video. If you have comments or questions, leave it under this video. And then next time we'll get into polynomials, okay? All right. Bye.